Seismic hazards. Seismic hazards refer to the risks associated with earthquakes and related phenomena, such as ground shaking, surface faulting, and secondary hazards like landslides and tsunamis. Earthquakes are natural geological events caused by the sudden release of energy in the Earth's crust, resulting in seismic waves that propagate through the ground. Seismic hazards can have catastrophic consequences, including loss of life, destruction of infrastructure, and long-term socio-economic impacts. The primary cause of seismic hazards is tectonic plate movement. The Earth's lithosphere is divided into several large plates that are constantly in motion, interacting at plate boundaries. Most earthquakes occur along plate boundaries, where tectonic forces build up stress and eventually exceed the strength of the rocks, causing them to rupture. The three main types of plate boundaries where earthquakes commonly occur are transform boundaries, where plates slide horizontally past each other, convergent boundaries, where plates collide, and divergent boundaries, where plates move apart. The intensity and impact of seismic hazards depend on various factors. The magnitude of an earthquake, which indicates the amount of energy released, is often measured using the Richter scale or the moment magnitude scale, MW. Larger earthquakes with higher magnitudes generally produce more intense shaking and can cause more significant damage. The distance from the earthquake source, the depth of the earthquake focus, and the local geology also influence the severity of shaking experienced at a particular location. Ground shaking is the most immediate and visible hazard associated with earthquakes. The shaking can cause buildings, bridges, and other structures to collapse or sustain damage, endangering human lives. The severity of shaking is influenced by factors such as the distance from the epicenter, the local soil conditions, and the duration of the shaking. Strong ground shaking can also trigger secondary hazards, including landslides, liquefaction, the temporary loss of soil strength leading to ground failure, and soil amplification, the intensification of ground shaking due to specific soil types. Another significant seismic hazard is surface faulting, which occurs when the movement along a fault during an earthquake displaces the ground surface. Surface faulting can lead to the rupture and deformation of infrastructure, as well as the disruption of natural drainage patterns and groundwater flow. Active fault zones require careful consideration in land use planning to minimize exposure to potential surface faulting hazards. Tsunamis are another type of seismic hazard, typically associated with undersea earthquakes or large submarine landslides. These powerful ocean waves can travel great distances and cause devastation along coastlines. Tsunamis can result in massive flooding, coastal erosion, and destruction of coastal infrastructure, leading to significant loss of life and property damage. Early warning systems, coastal zoning regulations, and public education efforts are essential for reducing the impacts of tsunamis. Seismic hazard assessment and mitigation are crucial for reducing the risks associated with earthquakes. Scientists and engineers use various techniques to understand and map seismic hazards, including historical records, geophysical surveys, and modeling. This information is used to develop building codes and engineering practices that ensure the construction of structures capable of withstanding seismic forces. Retrofitting existing buildings to improve their seismic resilience is also important. Furthermore, emergency preparedness and response plans play a vital role in mitigating the impacts of earthquakes. These plans include public education on earthquake safety, the establishment of emergency communication systems, and the training of first responders. Seismic monitoring networks allow for the rapid detection and assessment of earthquakes, enabling timely response and evacuation measures. In conclusion, seismic hazards pose significant risks to human populations and infrastructure. Understanding the causes and characteristics of earthquakes, as well as implementing appropriate hazard assessment, mitigation, and preparedness measures, are essential for reducing the impacts of seismic events. Through a combination of scientific research, engineering practices, and public awareness, societies can work towards enhancing their. Please don't forget to subscribe to my channel and turn on notifications.